Now, in our physics subject, now we are going to discuss heat chapter. In this one, first, before going to discuss that heat chapter, first we have to define what is heat, what is temperature, what are the differences between. First, heat means it is an mobile form of energy. That is a moving form of energy, transmission form of energy. Suppose our unhealthy human body temperature is 30 here, an healthy human body temperature is 36.9 degrees Celsius, 37 degrees Celsius approximately, 98.4 Fahrenheit, 310 Kelvins. Suppose in this hand one hot coffee is there, in this hand one ice cube is there. The left hand feels cool, the right hand feels hot. That is, from high temperature region to low temperature region, the mobile form is not temperature, the mobile form is heat. The transmission form is, it is a mobile form of energy, heat. Heat can flows up from high temperature region to low temperature region until get the both temperature, until get the similar temperature. From high temperature region to low temperature region, heat can flows. It is a mobile form of energy. It is the net intensity of hotness or coldness. It may be any one. Suppose three cold drinks are there. One is cool. The second one is somewhat more in cool. The third one is very, very, very chilled. Now in these three, all are cold, but in which case the intensity of coldness is more? In the third situation, the intensity of coldness or hotness measures in terms of temperature. It is the heat. Mobile form, it is a net intensity, right, called as temperature. It is not a mobile form. It is the mobile form is the heat. The units of the heat is calories, kilocalories, joules. What are the units for the temperature? Degrees Celsius, Kelvin, Fahrenheit, and the Reimers. And another one is the wrong kinds. The wrong kinds are not in practice now, but the Reimers are some in European countries. Now also it is in practice. Reimer. These are the units of the temperature. SI, international standard unit, is the Kelvin of the temperature. Next, what is the measuring apparatus of heat is calorimeter. The measuring apparatus is calorimeter. The measuring apparatus of temperature is thermometer. The calorimeter working principle is how much of heat lost by the hot body, how much of heat gained by the, that is equal to the how much of heat lost by the hot body, that is equal to how much of heat gained by the cold body. The working principle of the calorimeter. How much of heat lost by the hot body is equal to how much of heat gained by the cold body. It is the heat. That is a calorimeter working principle. It is. What about the thermometer working principle is? On heating, every substance expansion will be takes place. On heating, expansion will be takes place. Based upon this principle, thermometer works. The thermometer determines, records the temperature. The calorimeter used to measure the heat. Calorimeter, thermometer. Another one is here, bomb calorimeter. What is the bomb calorimeter? Here, suppose 10 grams of milk is there. There's a 10 grams, suppose 100 grams of cow milk, 100 grams of buffalo milk, 100 grams of meat, 100 grams of chocolate. Cow milk, buffalo milk, meat, either chicken or mutton, or it may be any non-veg meat, 100 grams of right, our chocolate, cow milk, first cow milk, buffalo milk, meat, chocolate, 100 grams is there. From which substance more amount of energy releases? I am not asking proteins, vitamins, lipids, carbohydrates, right? I am the amount of energy which is released from which substance, the maximum amount of energy which is released from which substance. 100 grams of substance, if we consume, if we utilize, if we digest 100 grams of cow milk, 100 grams of buffalo milk, 100 grams of meat, 100 grams of chocolate. Answer is, sir, no doubt, chocolate. Why? Because here the cow milk from the 100 grams of substance releases, that is the 67 kilocalories of energy from the cow milk. What about the buffalo milk? From buffalo milk, 116 kilocalories for 116 kilocalories. What about the meat? 118 kilocalories. What about the chocolate? 344 kilocalories of amount of energy will be releases. That's why more amount of energy will be releases from that chocolate in this four. Right, the amount of energy which is released from an food material, by the help of, we can calculate bomb calorimeter. By the help of bomb calorimeter, how much of energy will be released, how much of energy will be releases from that object, we can calculate by the help of bomb calorimeter. Right, here it is a bomb calorimeter. There is a calorie per gram, kilocalorie per gram, right? It is a bomb calorimeter, thermometer. Right, here there are four types of substances. There are 4 states of substances are there. That is a solid, liquid, gases. The fourth form of the substance is plasma state. The solid, liquid, gas are present at room temperature, some substances, but the plasma occurs at high temperatures and high pressure regions only. That is, at the surface of the sun, plasma state. The fourth form of the substance is the plasma state. The fourth form of the substance, that is a plasma, exists on the surface of the sun as well as at the center of the earth. At the center of the earth, 6000 degrees Celsius will be there, as well as high pressure will be there. That is, at high pressure and high temperature regions, the existing form is the fourth form. That name is plasma form. Now if we discuss as room temperature, there is 3 states can exist. That is the solid, liquid, gaseous form. On heating, solid converts to liquid. That process is well known to us, melting process. On heating, liquid converts to gas, boiling process. On cooling, the gas particles, they comes to liquid, called as condensation. In cooling of liquid is converts to solid, that is a freezing process. Some substances are there like naphthalene balls, camphor. These substances convert from directly solid to gaseous or gaseous to directly solids without any liquid form. That process is called as sublimation process. Conversion of solid to gaseous to solid without any liquid form, called as sublimation. Which one of the following is not an sublimable substance? A, B, C, D. Question will be like here. How to remember? Number of sublimation substances are there, but regular daily life examples are required to us. The number 1 is the naphthalene balls, which we are using in the beer was to the cloths, in the naphthalene balls, right? As well as in the urinals also we use the naphthalene balls. As well as another one is the camphor, right? In temples, commonly in the house, right? camphor. The third one is the ammonium chloride, NH4Cl. NH4Cl, ammonium chloride. Ammonium chloride also it is an sublimable substance. Commonly ammonium chloride used to the construction of the dry cell, that is which we are using in the torchlight battery will be there, dry cell. In that one white color paste will be there, that white color paste ammonium chloride only. This ammonium chloride also used in the daily life in soldering process to in the repairing of the motherboards of electronic goods, in the repairing process, soldering process also. As well as another one is there is a dry ice. Commonly ice chemical formula is H2O, but dry ice nothing but solid carbon dioxide is called as dry ice. The carbon dioxide which is present in as a pollutant, which is present in the atmosphere, if we convert the carbon dioxide, gaseous carbon dioxide, in cooling the temperature, the carbon dioxide gas is converted to liquid as well as converts to solid carbon dioxide. If we convert the carbon dioxide, gaseous carbon dioxide into solid carbon dioxide, it will be an white color solid. That one is a solid carbon dioxide, is a white color solid substance. How to maintain the low temperature? It is high expensive process. That's why when it is converting the gaseous carbon dioxide to solid carbon dioxide, it is a high expensive process to maintain in the solid form only. That's why we drop in the natural refrigerator, that is the oceans. On the bottom of the oceans commonly records minus degree Celsius also. At that is a natural refrigerator is oceans. Now the excess of carbon dioxide gas converting into the solid carbon dioxide, that is a dry ice, and once again drop into the natural resource, natural refrigerator, that is the oceans. By this process we can decrease the carbon dioxide percentage as a pollution in that atmosphere. Right, there's the dry ice, there's a solid carbon dioxide. The solid carbon dioxide also converts from solid to directly gaseous without any liquid form. It is an example for the sublimation process. Ice chemical formula H2O. Dry ice chemical formula solid carbon dioxide. What about another one is there, burning ice. The burning ice means the methane gas which is present in the ice. Recently the China scientists are announced that in the pole region, in the Antarctic region, that the ice which is present in the Antarctic region, in that ice methane gas is present. If we extracted the methane gas from that ice, that's why that ice is named as chance to extract the methane. The methane is an flammable gas we can use as a fuel. There's a natural gas. That's why here the burning ice. The burning ice means the methane which is present in ice. The burning ice chemical formula is methane plus ice. What about the dry ice? Solid carbon dioxide. What normal ice? H2O. Here another one is the solid iodine. Solid iodine also, it is an sublimable substance, converts from solid to directly gaseous. Right. Here on heating, ice converts to water. Melting process. At melting point, on heating, water converts to water vapor. There's a boiling process at boiling point. On cooling, the water vapor converts to water. Condensation process. In cooling, water converts to ice. That process is well known to us, freezing process. Here in the summer session, due to evaporation, the water level of the water reservoirs like lakes, ponds, wells, oceans will be decreases due to formation of clouds. The formation of clouds. In clouds, water vapor particles are there. Water vapor. The formation of clouds involves which principle? Boiling process. Right. Now, in normal rain, that is, water vapor converts to water. In normal rain or in artificial rain, the water vapor molecules are close to each other. When the temperature cools down, the water vapor molecules comes together due to less energy available in low temperature times. In low temperature, due to decreasing the temperature, the water vapor molecules are close together and joined together, form a big water molecule, and due to the gravity falls on the earth surface. That is normal rain or artificial rain. The normal rain or artificial rain working principle is the condensation process. Next, another one is the here's mango shower. That is the rain with ice cubes. The mango shower works based upon the behind principle in the mango shower. There is a rain with ice cubes in the summer session. In the summer region time, here the mango shower is due to the behind principle in that one is the water vapor is converted to directly ice. That's why sublimation process. Right. Suppose if we kept one water bottle in the refrigerator, after certain time, now we observe the water drops, the wet will be there, the outside walls of the water bottle. Where it will comes here? Why? Because in the refrigerator, due to less temperature, due to low temperature, less amount of energy is availability. The water vapor which is present in that atmosphere, the atmosphere water vapors comes to close to each other and forms a big water drop molecule, and due to gravity falls in the downward direction. The water bottle, right, the walls of the water bottle appears to us due to in that principle also, right, condensation process only. Right. Here the measuring temperatures are, the measuring units of the temperatures are degrees Celsius, Fahrenheit, Reimer, Kelvin. Right. Now, the interrelationship between these temperature measuring units are C by 100 is equals K minus 273 by 100 is equals F minus 32 by 180 is equals R by 80. R stands for Reimer by 80. There is a wrong kinds are not in practice in anywhere, but the Reimers are now also practicing in some European countries. Right here, the relationship is degrees Celsius, C by 100, K minus 273 by 100, F minus 32 by 180 is equals R by 80. Right. Now, if we take the relationship between the degrees Celsius and the Kelvin, C by 100 is equals K minus 273 by 100. If we cancel 100 gets cancelled, that is C, if we bring to here, C plus 273 is equals K. C is equal to K minus 273. If we bring the minus, it will become plus. C plus 273 is equal to K. That is, if we join 273 value to degrees Celsius, it converts to Kelvin scale value. Right. Suppose question number 1, calculate an healthy human body temperature in Kelvin scale. The principle is C plus 273 is equal to K. Now, the healthy human body temperature well known is 36.9 degrees Celsius. If we write approximately 37 plus 273, nothing but 310 kelvins. Right, 310 kelvins. Question number 2, calculate the pasteurization temperature. First, what is the pasteurization process? Killing of microorganism by adding of heat energy. Killing of microorganism up to 67 degrees Celsius to 72 degrees Celsius. We have to heat up to 15 seconds minimum. Right. Calculate in Kelvin scale. Suppose if we take 67 degrees Celsius, 67 plus 273, nothing but 340 kelvins. right? In that method also calculate the room temperature. Suppose we treating as 27 degrees Celsius as the room temperature. A calculation in, right, C plus 273 is equal to K, right? That is a 27 plus 273, nothing but 300 kelvins, right? Approximate, right? Okay. Alright, 300 kelvins. Next, calculate the at what value coincide. Suppose question will be like, suppose the melting point of ice is 0 degrees Celsius, well known to us. 0 degrees Celsius, melting point of ice 0 degrees Celsius. Next, if the calculate the melting point of ice in Kelvin scale, that is C plus 273 is equal to K. If we substitute at C is equal to 0, C 0 plus 273 nothing but 273 kelvins. If we calculate in the Fahrenheit, C by 100 is equal to F minus 32 by 180. If we write C is equal to 0, 0 by something 0, into 180 is 0, that is 32 Fahrenheit directly. That is, we can calculate, we can write the melting point of ice in different units is 0 degrees Celsius, 100 degrees Celsius, 32 Fahrenheit as well as 0 Reimers. The boiling point, if we convert into that, the boiling point of water is 100 degrees Celsius. If we convert into the different scales, there is a 373 kelvins, 212 Fahrenheit and 80 Reimers. Suppose if you calculate the, suppose your C by 100 is equals R by 80. It is a relationship between the degree Celsius and the Reimer. If we calculate, if we convert the boiling point of the water, that is 100 degrees Celsius by 100 is equals R by 80. 100 gets cancelled. Now the Reimer value is 80. That is 80 Reimers. We can convert to any unit. That is a melting point of ice is, the values are directly we can write 0 degrees Celsius, 273 degrees Celsius, 32 Fahrenheit, 0 Reimers. What about the boiling points of the water is 100 degrees Celsius, 373 degree Kelvins as well as 212 Fahrenheit, 80 Reimers right here. Now the universal solvent is water, well known to us. Here thermometer nothing but it is a measuring instrument. Every measuring unit, every measuring instrument consists of starting point and the ending point in the readings. The starting point it is named as LFP. LFP nothing but lower fixed point. The ending point of the thermometer commonly known name as UFP, that is the upper fixed point. The lower fixed point, the melting point of the ice commonly treating as UFP, nothing but LFP, nothing but lower fixed point. The boiling point of the water now we are treating as UFP, nothing but upper fixed point. Right here in the degree Celsius thermometer, Kelvin thermometer, Fahrenheit reading thermometer, Reimer readings containing thermometer. That is the UF, that is the first LFP. LFP nothing but melting point of ice. There is a 0 degrees Celsius, 273 kelvins, 32 Fahrenheit as well as 0 Reimers. What about the upper fixed point? 100, there are boiling points, 100 degrees Celsius, 373 kelvins, 212 Fahrenheit, 80 Reimers, right? Okay, that is if we difference the 100 upper fixed point minus lower fixed point, 100 minus 0, 100, there is C by 100, 373 minus 273, 100, that is a K minus 273 by 100. Next 212, 212 minus 32, 180, that is a F minus 32 by 180, 80 minus 0, R by 80, right here. Right here another question is, at what value coincide the Fahrenheit scale and the degree Celsius scale? Here suppose It is the fourth question. That is the at what value coincide the Fahrenheit scale as well as degree Celsius scale. Suppose both are coincide nothing but we have to take same value x. Then if we substitute in that one, x by 100 is equals x minus 32 by 180, 0 0 gets cancelled. In cross multiplication, 18x is equals 10x minus 320. 10 into x, 10x minus 320. X terms are one side, without x another side. If we bring minus, that is 8x is equals minus 320, x is equals minus 40. At a minus 40 degrees Celsius and Fahrenheit are coincide with showing same temperature at minus 40 value. Right. Another question is, which scale doesn't contains negative values? Here, before going to this one, we have to learn here one question. Identify least temperature of the following. That is, first question is the option is the minus 100 degrees Celsius, minus 202 degrees Celsius, minus 186 degrees Celsius, 0 Kelvin. Identify the least temperature among the four. Now, which one is the least temperature? Minus 100, minus 202, minus 186, 0 Kelvin. Which one is? No doubt 0 Kelvins. Why? Because well known to us C plus 273 is equals K. To get 0 kelvins, we have to write minus 273 plus, at that time only we will get 0. That's why 0 Kelvin or in another terms minus 273 degrees Celsius. Right, now minus 100, minus 273, minus 202, minus 186 be among these four, which one is the least temperature? Minus 273 or 0 Kelvin is the least temperature. First here, solid, liquid, gas. As we are lowering the temperature, the gaseous, that is away from, that is the particles are close to each other, once again close to each other. At 0 degrees Celsius, it very nearer to each other. That is the solid form for the H2O, that is the ice. Now we are at it is at 0 degrees Celsius, ice is there. Now we are decreasing the temperature up to minus 10, once again close to each other. At minus 100, once again close to each other. At minus 200, once again near to each other. When it is reaches to minus 273 degrees Celsius or 0 kelvins, the volume size becomes 0. Now at minus 273 degrees Celsius, at 0 degrees Celsius, now the volume of the substance very least. the how much of the volume will be there, that is treating as a 0. How much of the volume it will be contains, that volume now we are treating as 0. That's why minus 273 degrees Celsius or 0 kelvins are named as absolute zero temperature. Right, absolute zero temperature nothing but minus 273 degrees Celsius, 0 degree. At what temperature the volume of the substance now we are treating as 0 or negligible or disappear will be takes place. Right, and now below to minus 273 degrees Celsius or below to 0 Kelvin, there is no visible, that is there is no the volume now treating as 0 at 0 kelvins. Below 0 kelvins it is an imaginary. That's why which scale doesn't contains negative values, that is the Kelvin scale. Because of minus 1 Kelvin, minus 2 Kelvin, minus 3 Kelvin, these are all the imaginary values. That's why which scale doesn't contains negative values, nothing but Kelvin scale. In the degree Celsius, okay, 0, minus 10, minus 100, minus 4, minus 5, minus in the degree Celsius scale negative values are there, but what about in the Kelvin scale? Negative values are there. 0 degrees Celsius nothing but minus 273 degrees Celsius. At that temperature only the volume size of the object becomes disappears, the size, the volume now we are treating as 0. That's why the least temperature in the Kelvin scale is the 0 Kelvin only. That's there is no negative values in the absolute 0 temperature less than 0. There is no negative values in Kelvin scale. There is in the Kelvin scale 0 Kelvin is the least temperature. Right.